Now that we've seen a little bit about variables and how to store data, we're going to talk about working with data, specifically performing computations. The original computers were people, and a computer is just someone or something who can or that can compute, generally do arithmetic. And the reason that computers, the electronic computer, is so powerful is that it is able to run these computations much faster than a person could do them by hand or in their head. So we're going to start by opening Visual Studio Code so we can see what some of these computations we can run in Java and other programming languages. So we see we got to wait for Java 11, the environment to boot up. This can always take a minute, especially if you have several extensions, like I have several extensions on my machine. But we see the run up here, so we're good, and we can see that the last bit of escape codes from last time is still here. So we'll just delete those two lines, making sure we don't touch the braces. So first, we're just going to run through some quick computations, and these will be pretty straightforward. And I'm just going to print them in line. So one thing you can do with two numbers is you can add them, right? You can do 2 plus 5. And if math acts as we have expected it to since kindergarten and first grade, we should see 7. So in Java, the plus sign is what we call the addition operator. It takes two values and adds them together. We can also have subtraction, 5 minus 3. And in this case, the minus sign is referred to as the subtraction operator. And if we run this code, we get 2 because 5 minus 3 is 2. We can also multiply two numbers together because the asterisk is the multiplication operator. We'll save that and then we'll run it. And 5 times 3 is 15, so we get 15. Now we can also run these computations and store them in a variable, and I'll just say int result equals, and we'll do 5 plus 3, and we will just print the result. So notice that with println, you can actually print a variable and get the value out of that memory, or you can just type in the computation and get it directly that way. We'll stick with the variable for now just so we can see it. So here's our addition, and 5 plus 3, this case is 8. 5 minus 3, we get 2, and 5 times 3, we get, hopefully, 15 again. So that, I hope, is kind of all working as you would expect. And we can also flip these around because addition and multiplication are commutative. So 3 times 5 still gives me 15. 3 plus 5 still gives me 8, and 3 minus 5, which subtraction is not commutative, gives me -2, which is what I would expect for an integer. Remember, integers include positive numbers, 0, and negative numbers, as long as they are whole numbers. So those are 3 of your 4 expected operations. One operation that tends to give people trouble is the division operator. And this can be pretty straightforward. For example, if I have 8 divided by 4, I would expect a result of 2, which I see here. If I had 104, I would expect 25. So far division has acted like all the others, no problem. The problem arises where, let's say we try to do this division. 3 divided by 2. Now, if you're doing this on your calculator or in a math class, right, by hand, you know that 3 divided by 2 is 1.5. But when we run the code, we just get 1. And this is the thing that kind of gives people trouble at first. But if you think about the data, it starts to make a little more sense. An int is an integer. It is a whole number, no decimal part. So that means anything that we do over here has to end up being an integer, a whole number with no decimal part. The problem is that 3 divided by 2 does have a decimal part. We get 1.5. But because we're going to stick it in an int variable, we can only stick the whole number part of the answer in there. And so because the 0.5 was an extra bit of data, it just gets dropped off. So notice we didn't round, we just dropped the result. And this is what's called truncation. The result gets truncated. The part after the decimal gets totally ignored because the computer doesn't care if it was just a little bit after the decimal or a lot after the decimal. It cares that there was anything after the decimal. And because of that, we're left with only the int, only the integer part, only the whole part of the answer. So that's why if you're doing division with integers, you might see some results you don't expect. For example, 10 divided by 7 is going to be a pretty weird decimal result. But when I run this, I just get 1 because 7 goes into 10 one time, and then there's a remainder. And the remainder is kind of what's more important here. At a certain point in learning math, you got to the point where you would say that, let's say, 5 divided by 2, well, is it 2 with a remainder of 1, or is it 2.5? For the first several years of your schooling, when you were talking about division or the idea of division, you got a quotient with a remainder. But then after a certain point, after you got comfortable with decimals and fractions, more so with decimals, you would start writing it like this. So the computer is actually not doing it like this. The computer is doing it like this. It's finding out how many times does the bottom number go into the top number, and then what's the remainder. So when I run this, the computer said, okay, 5 divided by 2. Well, that's 2, and now I'm going to ignore the remainder. Now, if the bottom number is bigger than the top number, right, how many times does 8 go into 5? Well, it goes into 5 0 times. And if I run it, I get 0. And so this is an issue when you're working with integers, is that division is only going to give you the quotient, the whole number of times the bottom number goes into the top number. Now there's another operation that we'll talk about in a minute, but just so that you see that all of these are working kind of the same, we'll do the same thing with a float. Or rather, we'll do it with a double, since that's Java's default. And we'll go back to the operations we were looking at. We had 5 plus 3, and I'll print the result. But just before I do, just remember that you can use integers as doubles, because an integer is just a decimal number without a decimal, but you can't use a double as an integer all the time. So I'll run this, and I get 8.0. Notice I got that 0.0 in there now. It's because that result is a double. If I do 5 minus 3, I get 2.0 again because it's a double. If I do times 3, I should expect 15.0, and that's what I get. So far, we know that addition, subtraction, and multiplication all work the same. Now let's see what happens with division. Oops. When I run this, I still get 1.0. which is not what we would expect. We're working with a double now. We would think, okay, if I'm working with a double, I should get the real answer, the whole answer. But that's not what happened. Here's why. Java didn't say 5 divided by 3 is 1.66666 repeating. It said, okay, 3 is an integer and 5 is an integer. 3 goes into 5 one time with a remainder. I'm going to ignore that. So the answer here is 1. And oh, they want me to stick it in a double. I better make it 1.0. So I'm going to change it up a little bit. I'm going to rename this as int result so you can see what happens with ints. And I'm going to also make another one called double result, which is slightly different. Now I'm going to print both of those. So the only difference between these two lines is that this one is 5.0 divided by 3, and this one is 5 divided by 3. Said another way, this is an int divided by an int, and this is a double divided by an int. If I run this, now I see a difference. So one thing with computing, remember, is that we're going to start on the inside and work our way out. So Java here saw 2 ints, and it said, okay, there's 2 ints. I'm going to divide them like they are ints. And it got a result of 1, and then it stuck that in a double variable, turning the 1 into 1.0. But when Java saw this, it said, okay, I've got a double and an int. I better treat these like doubles. And when it did that division, it got 1.6 repeating, and then it stuck the answer in a double variable. This would have worked either direction. So even if I had done 5 over 3.0, I get the same answer. And if they were both doubles, I would have gotten the same answer. A good rule of thumb is for doing double arithmetic, any floating point arithmetic, if you want the answer to be a double or a float, you had better make sure at least one of the numbers you're working with is a double or float. And there's a few ways to do that. For example, I could have just added the decimal 0 like I did before, or I can just say double. Let me fix my syntax. Oops, sorry, closed that out, didn't mean to. So we'll save that, run it. And now I get the right answer again. So there's a few ways to handle this, but this is probably the most straightforward. In fact, it may be the case, let's see if Java likes that. Yeah, you don't even need the 0, just a decimal point will suffice. So that's something to keep in mind, that division only works the way you expect it to if the answer is a double and at least one of your numbers is a double. And just so we see what happens, what if I did this? Now Java's complaining because can't convert from double to int. Java already recognized, hey, 5.0 divided by 3, one of those is a double, so the answer is a double. But I can't put a double inside of an int. I can put an int in a double, but I can't put a double in an int. And we'll go back to that. So we'll make a note here that doubles and ints have a slightly different workflow there. So those are your 4 major operations, but I want to back up a little bit and talk about integers again, because there's one more operation you can do with integers. I believe this works with doubles as well, but we'll stick to talking about it with integers because that's where you'll see it most often. And I'm going to make a note here. We're going to call this result the quotient, 5 divided by 3. And we're going to print our quotient. Remember, quotient is just the mathematical term for when you divide two numbers. What is the first part of the answer here? Not the remainder, but the quotient. And 3 goes into 5 one time, so the quotient is 1. But there's another thing we can do. We can actually calculate just a remainder. Now the forward slash means division, but the percent sign means remainder, or really the term is modulo, M-O-D-U-L-O, or modulus division. Modulus division operator, or we can just call it the modulo operator. And we'll say System.out.println remainder. And so what this operator does is it acts as though it's doing the division, but it doesn't care about the quotient. It just cares about the remainder. So 3 goes into 5 one time for the quotient, but then you get a remainder of 2. And I'll run that, and I get the quotient was 1 and the remainder was 2. And you don't need to do both of these together. Doing just one or just the other is perfectly fine. I'll even comment out the quotient lines. And remember, if it's a comment, it doesn't run. So only line 18 and line 21 is going to run. I'm going to click run here, and I get just 2. And so there's a few things you can do here to kind of view that and see that happening, but all that's happening here is, remember, divide means give me the quotient, modulo means give me the remainder. And if I had flipped these, 3, 5, 3, 5, we know that 5 goes into 3 0 times, and 5 into 3 leaves 3 left over, because 0 is the quotient and 3 is the remainder. And if I run that, I get 0 and 3. So these are your 5 most common operators just for your traditional arithmetic. The first 3 act the same for both doubles and ints: add, subtract, multiply. Division, remember, division is going to give you just the quotient if you're working with integers, even if you store the answer in a double. But as long as at least one number you're working with is a double, it will give you a decimal result. It will give you the double result, not just the quotient. And then the modulo operator, again, should work with doubles as well as integers, but we'll see it more often with integers. And it gives you just the remainder, does not give you the quotient. So those are some terms you might want to review. And if you want as well, you can also do all this work with variables. So I can say that my first number is 3. I can say that my second number is 5. I can say my quotient is my first number divided by my second number. And I can see that my remainder is my first number modulus my second number. And I can run that code and get 0 and 3 again. But now if I want to change it, all I have to do is change it up here. So 30 and 5, 30 divided by 5 is 6. 30 modulus 5, 5 goes into 30 6 times with no remainder, so my numbers should be 6 and 0. So this is a good area to kind of practice, is plug in some numbers, use these operators, see if you get answers you expect or answers you don't expect. Remember that you can work with variables like this, or you can just put the expression inside of your println and do something like 3 divided by 5.0 and run it. And on that last line, you'll still get 0.6. Remember that each of these lines that ends in a semicolon is called a statement, and we'll be referring back to that again. And each of these computations we run is called an expression. So Those are two terms that we might have had floating around. In this case, an expression is a computation. There are other kinds of expressions, and we'll see what that means. But if you hear these two terms right now in these lessons, that's kind of what they're referring to. And that's going to kind of wrap up what we see with these kind of basic ideas of arithmetic. In the next video, we're going to start looking at other operators. So these are the 5 main operators you see first, where you can do your simple calculator math, but we will see a few others that are going to be used a lot as you start programming.